Fifth graders, it feels like it's been a while since we did a new lesson in Eureka Math, but today, don't worry, we are back and we're continuing right along. So far we've learned how to add and subtract decimals, and for the next few days we're going to practice multiplying decimals by whole numbers. And a lot of you probably, again, already know tips and tricks on how to do this stuff, like, oh, I moved the decimal point this many spaces and I move it this many spaces back. Give me a thumbs up if you know that trick. Very good. However, in this math class, as you guys know, we're not interested in tricks. We want to know why these tricks work and why our after school or our parents or our weekend math classes teach us these tricks. We have to be able to draw pictures in multiple ways to show why it works. And so today we're going to start the groundwork, the foundation, by drawing two kinds of pictures. We're going to be able to draw, by the end of today's math lesson for Eureka Math Module 1, Lesson 11, we need to be able to draw discs on a place value chart. We also need to be able to draw something called an area model. Okay, both of these strategies should be familiar to you because you know what place value charts are, and I would venture to guess that you worked with area models last year in 4th grade. Yes? Good. Today we're going to see how those things can extend to when we're talking about multiplying decimals by whole numbers. But first let's talk about the problem of the day. If I gave Shobit 2 apples, and then I gave him 3 copies of those 2 apples, how many apples would Shobit have? First I gave him 2 apples, then I made 3 copies of those, and I gave them all to him. 6, good, okay. When we multiply, I guess technically we had 8 because I gave him 2 first, and I made 3 copies of it, and I gave him 6 more, so he has 8. That's a lot of apples. We know that when we multiply, it's the same as making copies of something. Yes? Okay, so here I have 3 copies of 2/10. I can show that in a place value chart. I can show that at first I have 2/10 by drawing 2 discs in the place value chart in the tenths column. If I want to make 3 copies of it, how many copies do I have right now? 1. Here's 2 copies. Here's 3 copies. All together, what do I have? 6/10. And I can write that in standard form by putting a 6 in the tenths column. So 3 times 2/10 is 6/10. Using this repeated reasoning, let's try the next one. You can do like me and just draw a little line through it. This time I have 3/10. Let's draw 3/10. 1, 2, 3. How many copies of that do I want to make? 3 copies. So there's 1 copy, 2 copies, 3 copies. What do I have all together? 9 tenths. Thank you. I don't have 9. I also don't have apples. I have 9/10. And I can write that in standard form like that, 9/10. If the book or the test wanted me to write it in unit form and wrote out the words tenths, T-E-N-T-H-S, I could also respond accordingly. Yes? Good. Okay, go ahead and draw a line. Last example. I have 4 copies of 3/10. So let's start with 3/10. 1, 2, 3. How many copies do I need to make?
4.
I have 1 copy, so there's 2 copies, 3 copies, 4 copies. What do I have? 12/10. So I could write this as 12/10, but that's not in standard form, is it? We know that 10 of these can be regrouped, can't they?
Yeah.
10 of them equals 1, 1. So what I really have is 1, 1, and 2/10. I want to remind you, if I think of it in unit form, I can just write 12, and then the tenths tells me that my rightmost place value needs to be in the tenths place. In order for that to happen, I have to put the decimal point right there. Okay? So there's 2 ways for you to think about it. Regrouping, and I do want you to show, when regrouping is appropriate, I want you to show it on your place value chart, but you also know this trick with unit form. Using a place value chart is only half of the learning goal. The other half is using an area model. We're going to do half place value chart, half area model. See how that encompasses your entire learning goal? Copy down this problem. 2 times 0.43. What that means is we're making 2 copies of 43 hundredths. Now, instead of drawing 43 dots in the place value chart in the hundredths column, instead, let's just draw 4/10. Go ahead and draw your place value chart and give yourself 4/10 and 3 hundredths. 1, 2, 3. How many copies of that are we making? 2. So go ahead and make 2 copies. 1, 2, 3, 4. 4 more tenths and 3 more hundredths. So altogether, how many tenths do I have? Okay. How many hundredths do I have?
6.
So 2 copies of 43 hundredths is 0.86. Again, that's applying what we just talked about in the previous slide to use a place value chart. Now let's talk about an area model. Area models are used very frequently for multiplication because we know that when we want to find the area of a rectangle, we have to multiply the length times the width. Do you guys agree? Yeah. In order to find the area of this rectangle right here, I would have to multiply the length times the width. So if I make one of them the length, 2, and the other factor, 0.43, the width, is that the same thing as finding the area? Good. What is good is I can separate 0.43 into 2 parts. The 4 part, which is 4/10, and the 3 part, which is 3/100. Do you guys see that? And then if I separate and I divide my rectangle now into 2 smaller rectangles, I have one rectangle whose dimensions are 2 by 4/10. Do you guys agree? And then I have another rectangle whose dimensions are 2, still 2 here, but this part is by what? 3 whats? Good. And what an area model allows me to do is find partial products. Parts of the entire product. Partial means only part of it, and product is the answer to a multiplication equation. Okay? So how do I find the area of that blue part? Well, it's 2 times 4/10. 2 copies of 4/10. And I want you to write it like this inside the square. What is super important about this lesson is that you copy this format. If I make 2 copies of 4/10, what do I get? When I made 2 copies of 4/10, what did I get? 8/10. I want you to write that in unit form here, underneath. 8/10. Next, I have 2 times 3/100 here, right? Write it inside the box. And then when I made 2 copies of 3/100, what did I get? 600. Write it under the box. Now, if I have to add that, I can write them in standard form. 8/10, 0.8 plus 600, 0.06. And if I want to find the entire product, I have to add up the parts, add up the partials. So what's 8/10 plus 600? 0.86 or 8600. And we can see we get the same answer using the place value chart or using the area model. When we reach the end of our area model, we have partial products, 1.6, 0.08, and 0.012. In order to find the total product, we have to add those up, okay? Here is a step where lots and lots of 5th graders make mistakes. They do a very correct multiplication for all the partial products. They even write it in standard form correctly. Then they become too lazy to write this in standard algorithm. Is it in standard algorithm right now? No, because it is horizontal. When they don't do that, 5th graders often make mistakes in the adding. It's really, really sad when they do really good multiplication work, and at the very end, the very last step, they make a mistake. Okay, so write it into standard algorithm. To use the area model to represent the distributive property. Give me a thumbs up if you remember what the distributive property is. The distributive property says that when I multiply or divide, I have to do the same multiplication for every member or every place value that's involved in that number. What I mean by that is if I promise to give this table 5 copies of $1, or 5 copies of what they already have, I have to give Jonah 5 copies of it, Maria 5 copies of it, Adi, Gora, Andy, Kosh. I can't just give these 2 5 copies and leave these 3 out of it. Going back into the context of our math problem then, what that means is if I'm multiplying 6 by 1.21, I have to make 6 copies of the ones. I also have to make 6 copies of the tenths. I also have to make 6 copies of the ones. Hundreds, sorry. So do you see how when I use an area model, so multiply 6 by 1 by 2/10 and by 1/100, it's helping me distribute the 6 into the ones, into the tenths, and into the hundredths. Do you guys see how that works? So the area model really is just a visual representation of the distributive property.